All right, so I wanted to point out some things with you when dealing with section 6.1 with simple and compound interest. So I put this example on Blackboard. So we're comparing the growth in a $100 investment for 5 years at 10% simple interest per year and at 10% interest compounded annually, right? And seeing, exploring the differences with that. Let's see. So on page let's see, it's page 8 out of this chapter, right? So I think how the book codes that is 6-8, right? So page 8 in chapter 6, you'll see a definition of some functions. So we have y equals a times b to the x, and also p equals p naught times 1 plus r to the t, right? So just to give you a heads up, we will be using these equations a lot. There is another one using Euler's number, which we'll talk about in a moment, with continuous rate of change, right? But I just want to point out that this is like the general form of a of an exponential function, right? Y equals a times b to the x, right? Where x and y, x is my independent variable and y is my dependent variable still, right? When we have a line, we have y equals mx plus b, right? Where x is still my independent and y is my dependent. So notice here that x is being multiplied and added something, right? Very basic, but an exponential, x is an exponent, right? Which is why we call it exponential, right? So what I'd like to do is take a moment and show you some differences between the two, right? So with simple interest, I equals PRT, right? Interest equals principal times rate times time, right? That's how the interest paid is calculated, right? So this would be 10% times $100 times 1, right? They didn't write the 1 here, so we get $10. And then we take the old balance, which is 100, add in the $10 to get the new balance, $110, right? But with simple interest, the principal doesn't change, right? Notice 100 is the same all the way down, right? So this is going to remain the same, $10, $10, $10, right? So if we look at this as like a sequence, so we have 100 and 110 and then 120 and then 130 and then 140 and then 150, right? When we have a sequence, right, a pattern where you're adding a certain number each time, that is linear, right? So notice in between here, I'm adding 10 each time, right? Plus 10, plus 10, plus 10, plus 10. This is simply my slope, right? And this is a linear function, right? So if I were to graph these points, right? So I'll graph them real quick in my graphing calculator, right? So if I go to Stat, Edit, then I need to come up here and I'll do clear down and clear this list. And if I come over here and hit this N for year 1, 2, 3, so I'm just entering my X values in, and then come over here to the Y, entering in my values, so 110, 120, 130, 140, and then 150. Right? So I can graph that. So I need to change my window. So for X, maybe do 0 to 6, going up by 1. For Y, I'll do 0 to 200, going up by 20, maybe. Hit graph. Oops, I have some things I want to turn off. So I need to turn this off. And Actually, no, I want this on, but I want it to look like that. There. Now I have that, right? So there's a graph of my points. So you can see they all fall in a straight line, right? Or if you're not comfortable with the graphing calculator, right? We're using Excel in this class a lot. You can certainly do the same thing in Excel. Alright, so let me go split screen here. So I can type in my X and my Y. So we had 1, 2, 3, 4, whoops, 4, 5, and then my Y was 110, 120, 110, 120, 130, 140, 150. Right? So I can highlight this, insert, we can go to scatter plot. We're going to have the scatter plot really quick there, right? And if I do a line of best fit, right, to connect those, so add trend line, linear, and then you can even display equation and R squared value on the chart. And notice R squared is 1, which means we have a perfect linear correlation, right? So I just wanted to make this larger, right? So just doing that really quick, right? So just plotting those points, and what I want you to notice is if I draw a line connecting all those points, all the points fall directly on that line, right? They're all in sync, and there's an equation for that. So if I have some value and I just keep adding the same number to it each time, I always get linear, right? So that's the key thing that you want to pick up from that. So if I go back to my OneNote here, then now we can look at the compound interest. So with the compound interest, right, notice how the interest is calculated, right? We're taking 10% times the old balance, right? So we start out with $100. I take 10% times 100, and I get $10, which means I get a balance of 110, right? But then notice in the next year, end of year 2, we take the end of year 1 balance, and that's my principal, right? So I take 10% times the old principal each time, right? So like here, year 5 uses the year 4 principal, right? So so what's happening is if you notice, if I have a sequence 100, 110, and then 121, 133.10, and then 146.41, and then 161.05, what you'll notice is I'm multiplying by 1.1 each time. So times 1.1, right? Times 1.1, times 1.1, times 1.1, right? And it makes sense because if I want to have a 10% increase, right, I have to pay 100% and then have a 10% increase, which means I need 110%, right? And the multiplier for 110% is 1.1, right? So each time I'm adding 10% to the original amount, right? So when I'm adding a constant number each time, I get a linear function. But when I multiply a value each time, this is exponential. Right? So remember, exponential looks like this: y equals a times b to the x. Right? So in this equation, my b value here would be what I'm multiplying by each time. Right? So the 1.1. So we would have y equals, and I would have 1.1 to the x. Right? And then the a value, this is your initial value, which here would be, well, if we let this be an x value of 0, right? Then 100 would be my right. So just filling in those x values. Right, then 100 would be my initial value. So the equation would be y equals 100 times 1.1 to the x. Right? So that's the equation that I would get for this function. So if I were to throw this into Excel real quick, right? So the values that we have are 110, 121, 133.10, 146.41, and then 161.05, right? So if I make a scatter plot with these points, notice it is not quite a line, right? If I add a trend line, if I go to exponential, you'll see it's perfect, right? Where if I went to trend line linear, it may look perfect, but we know a little more. We know it's going to be perfect exponential, right? So I can add display equation on chart and have an R value, and here's what the output of R is, right? One thing you want to notice is this equation is in a different format using this E number. This E is called Euler's number. So Euler's number is simply just a constant like pi, right? So if I were to Google just, I don't know, 10,000 digits of pi, we can get this, right? So this is a website that lists out 10,000 digits of pi. Notice at the end it still has dots. The digits of pi never end, and they never have a pattern, right? So this is an irrational number, which means it's a number I cannot write as a fraction. So that's why we use a fancy symbol pi, right, for it. Euler's number is similar in that fashion. Euler's number, oops. So let me do 10,000 digits of Euler's number. Oops, I hit a Q keys here. Fix that. And we can find those, right? So there are 10,000 digits of E, right? So this is also never ending. It's in no pattern, which means it's irrational. And irrational means I can't write as a fraction. So this is a special number that we use called E, Euler's number. And your calculator has a button like e to the x power and also natural log. Those two buttons are very connected. So natural log is ln, right? So those two buttons are very connected to Euler's number, right? That's what they're using. And we're going to find out more about natural log in the coming chapter, right? So Euler's number here you can see is approximately 2.72, right, roughly. All right. So notice that this equation is a different form, so that's okay. We're going to work a little bit with that form and progress into how to use that specific form. Right? All right. Well, that's all I wanted to get in this video. So make sure you're reading the textbook and emailing me if you have questions. Thanks.